Hello students, today we're going to discuss JEE Main 2025 questions from the chapter Dual Nature of Radiation Matter, January attempt, that is attempt number 1. So we divided this chapter into two parts. Today we're going to see the first part, and also we have a page in Instagram and WhatsApp channel. Do join in the WhatsApp channel to explore more regarding physics, especially competitive examination, and also to watch more video like this. Don't forget to subscribe our channel. Now let us start the session. First question, the work function of cesium and lithium metals are 1.9 electron volt and 2.5 electron volt. Okay, so they have given two metal. With respect to that, they have given its work function. First one is cesium. The work function of that is 1.9 electron volt. Second one is lithium. The work function of lithium is 2.5 electron volt. If we incident a light of wavelength 550 nanometer on this surface, the photoelectric effect emission is possible for. So the question is, if they incident a light of wavelength 550 nanometer on the surface, in which metal the photoelectric emission is possible? Okay, so to find that, we have to find the incident energy E. To find energy E, we can choose the formula, that is E is equal to hc by lambda. So now we can substitute its value. So we know h and c are Planck's constant and velocity of light, they are constant. So we can substitute its value, or else instead of h and c, we can substitute 12400 electron volt Armstrong. So we can substitute this value, so it will be easy. By wavelength, so wavelength they have given in the form of 550 nanometer. Here I am going to substitute in the form of Armstrong. So that will be 5500 Armstrong. So this is energy E. Okay. Armstrong will get cancelled. Balance, the zeros will get cancelled. 124 by 55, that will be 2.25 electron volt. Okay. So this is the energy incident on both the metals. Fine. So we have a condition in photoelectric emission. The energy has to be greater than the work function. So we'll see the first metal. In the case of cesium, the energy is 2.25 electron volt and the work function is 1.9. So the work function is less and the energy of incident photon is more. Okay. So here the photoelectric emission will take place. But coming to the lithium, so lithium work function is 2.5. The incident energy is 2.25 eV. Here the work function is greater. Because of that, photoelectric emission will not take place. So the answer 1D cesium, option 2 is the right answer. Second question, a light source of wavelength lambda illuminates a metal surface and electrons are ejected with kinetic energy 2 electron volt. If the same surface is illuminated by a light of wavelength lambda by 2, then the maximum kinetic energy is. So they have given two conditions. In first condition, the initial wavelength is lambda. That time the kinetic energy of photoelectrons, that they got it as 2 electron volt. Okay. So coming to the second condition, if the wavelength is lambda by 2, what is its kinetic energy? Okay. So work function for the both the conditions are same. So work function for the first condition is 1 eV and for second condition also 1 electron volt. So now we will choose the formula. We can take the formula energy E is equal to work function plus kinetic energy. Okay. So first we will substitute the first condition. So instead of energy E, so since they have given wavelength, we can take the formula, that is hc by lambda, that is equal to work function is 1 electron volt and kinetic energy is 2 electron volt. So that will be 3 electron volt. So hc by lambda is equal to 3 eV. So this is condition number 1. And for the second one, they have given the wavelength lambda by 2. So hc lambda by 2 means lambda. So 2 will go to the numerator, that is equal to work function is 1 eV plus kinetic energy will be Ke dash. Okay. So this is the second condition. So now we need kinetic energy. So I'm gonna divide this two equation. Because of that, hc by lambda will get cancelled. Balance 1 by 2 is equal to 3 by 1 plus kinetic energy dash. So if we cross multiply means 1 plus kinetic energy dash is equal to 2 3s are 6. So kinetic energy dash will be 5 electron volt. Okay. So the kinetic energy of photoelectron is 5 electron volt and option 3 is the right answer. Next one, in photoelectric effect, EM wave is incident on metal surface and electrons are ejected from the surface. If the work function of metal is 2.14 electron volt and stopping potential is 2 volt, what is the wavelength of EM wave? So first we'll take the given data. They have given the work function. Work function is 2.14 electron volt and then they have given the stopping potential. From that we can find the kinetic energy. So kinetic energy formula is QV. So Q is a constant, so charge of an electron. So instead of Q we can substitute E. So we can write kinetic energy as, so stopping potential is 2, so we can write it as 2. Instead of Q we can substitute E, so EV. Okay, so this is the kinetic energy. They have asked wavelength of EM wave. To find wavelength of EM wave, first we will find the energy of a EM wave. So we can take the formula E is equal to work function plus kinetic energy. So the work function is 2.14 electron volt and kinetic energy is 2. So that will be 4.14 electron volt. So this is the energy of EM wave. So from this we can find its wavelength. We can take the formula E is equal to hc by lambda. So lambda is equal to hc by E. Okay. Again in the place of hc we can substitute the value, that is 12400 electron volt Armstrong, and the energy we got it as 4.14 electron volt. Okay. So here the electron volt will get cancelled. Balance you will get it as 12400 by 4.14 Armstrong. Okay. So you will get the value in the form of Armstrong, but they have given the answer in the form of nanometer. Okay. So first if you cancel this value means you will get the answer as 2995 Armstrong, or else you can write it as 299.5 nanometer. Okay. So the close to the right answer is 300 nanometer. So approximately we can write the wavelength of EM wave is 300 nanometer. So option D is the right answer. Next one, a subatomic particle of mass 10 power minus 30 kg is moving with the velocity 2.21 into 10 power 6 meter per second. Under the matter wave consideration, the particle will behave closely like. Okay, so they are asked which type of EM radiation. To handle this question, first we have to find the wavelength. Only then we can find its respective radiation. So to find the wavelength, I am going to take the formula lambda is equal to h by p, where p is the momentum. So for momentum, we have a formula mass into velocity. So in given data, they have given mass and velocity. So we'll substitute the value. So lambda is equal to 6.64 into 10 power minus 34, and mass they have given it as 10 power minus 30, and velocity is 2.21 into 10 power 6. Okay. So if you're taking minus 30 to the numerator means it will become plus 30. So overall you will get the power as 10 power minus 10, and balance if you cancel 2.21 and 6.64 means approximately it will be 3. So 3 into 10 power minus 10 meter. So this is the wavelength. So this wavelength range will come under X-ray. So option B is the right answer. Next one, it's a theory question. In photoelectric effect, stopping potential V0 versus frequency nu curve is plotted. So this graph we have seen in the theory itself. So totally for the photoelectric effect we have 4 graphs. Last one is frequency with respect to the stopping potential. So the graph will be linear and it will not start from 0 because this part is a minimum frequency that you call it as threshold frequency. Okay. So from this graph we have to find which are the statements are correct. Okay. So first we'll see the first statement A. Stopping potential V0 versus frequency is linear. So the graph is linear only. So statement A is correct. And second statement B. The slope of V0 versus frequency is work function by Planck's constant. It's an incorrect statement because the slope under stopping potential and frequency is h by E, where h is a Planck's constant, E is a value of charge. So second statement is incorrect. And third one, h is constant related to the slope, stopping potential versus frequency. So h is a Planck's constant, always it's a constant only. So statement C is correct. So next one D, the value of electric charge of electron is not required to determine h using stopping potential versus frequency. It's an incorrect statement. To find the value of h, we need the value of charge. So it's an incorrect statement. So E, the work function can be estimated without knowing the value of h. That's a correct statement because work function depend only on nature of the material. So we don't want the value of h to find the work function. So that's a right statement. So the correct statements are A, C and E. So we'll check the option. Option 3 is the right answer. Question, the ratio of power of a light source S1 to the light source S2 is 2. So we have given the ratio of power. First we'll take the given data. So P1 by P2, that is equal to 2. S1 is emitting 2 into 10 power 15 photons per second at 600 nanometer. If wavelength of the source S2 is 300 nanometer, then the power of photoelectrons per second. So we'll take the given data. They have given two sources. In the first source, the number of photons per second is 2 into 10 power 15 and wavelength is 600 nanometer. And for the second source S2, the wavelength is 300 nanometer. We have to find number of photons per second. So for that, we'll choose the formula, that is power is equal to N into E. So in the place of E, we can expand the formula since they have given the wavelength. We can take N into Hc by lambda. Okay. So first we'll substitute the value. P1 is equal to, instead of N, we can substitute 2 into 10 power 15 into Hc is a constant and wavelength is 600 nanometer. And for the second power, P2 is equal to N, we have to find Hc is a constant and wavelength is 300 nanometer. Okay, so now we'll take the ratio. So if you're taking ratio, Hc will get cancelled, nanometer will get cancelled, 0 will get cancelled, this will be 1 and this will be 2 and this 2 again this 2 will get cancelled. So balance P1 by P2 is equal to 10 power 15 by N. So the ratio of P1 by P2 is 2. So 2 is equal to 10 power 15 by N. So N will be, N is equal to 1 by 2 into 10 power 15, that is 0.5 into 10 power 15. They have asked in the form of 10 power 14. So we can write it as 5 into 10 power 14. So answer 5 is the correct value. Okay students, we came to end of the session. If you have any doubts or queries regarding this video, do comment in the comment box. And to watch more video like this, don't forget to subscribe our channel. Thank you students.